Hello, my dear students. Let us take one more example on IS code method. What will be the percent reduction in the load capacity of the footing of example 1 if the water table rises up to a base of the footing, and the second case is 1 meter below the base of the footing. Assume that saturated unit weight of the soil is 19.5 kilonewton per meter cube. This is the continuation of the first problem. Okay. In the first problem, there were no water table effects, but here it is asked to find the load bearing capacity or percentage reduction in the load capacity when the water table rises up to the base of the footing, and one more case is when the water table rises up to a 1 meter below the base of the footing. So two different cases are there. So we have to calculate first bearing capacity, and then percent reduction in the load capacity has to be calculated. So here it is given saturated unit weight, okay, 19.5 kilonewton per meter cube. Other things you can use the same data from the previous problem, that is NC, NQ, N gamma, and B and D values, everything. Okay, see, one thing here what you can do is there are three terms in the equation, right? IS code equation. So the first two terms, there is no change in the value, it remains same. Okay, only there will be change in the last term, that is wedge term. Why? Because there is gamma, okay, and there is a water table effect. Other first two terms, C and C, that is same, there is no change. Even second term, NC and NQ minus 1 gamma D, there is no change. Okay, only the last term has to be changed. So you consider only that last term here, then remaining things are same. Okay, so what last term says, actually you understood, no? This is the formula. Okay, this is the formula. QNF is equal to CNC SCDC IC plus C gamma dash into NQ minus 1 SQ DQ IQ plus half of beta gamma N gamma S gamma D gamma I gamma W dash. But here there is no change in any values. Okay, only there is change here, gamma value and water table effect. So only this term we will calculate. Okay, how to calculate that? Half into beta gamma N gamma S gamma D gamma I gamma W dash. Here water table effect you have to consider. What it says in this case, W dash is equal to 0.5. Why? Here as per this, I have shown this in the last theory explanation. If the water table is likely to permanently remain at or below the depth of beneath the ground level surrounding the footing, then W dash is equal to 1. This was the first case. Next, if the water table is located at a depth or likely to rise to the base of the footing or above, then the value of W dash should be shall be taken as 0.5. This is our case now. At the base of the footing, water table is at the base of the footing. Next case is if the water table is likely to permanently get located at a depth between this D less than dW less than D plus B, then W dash be obtained by linear interpolation, that is given by using this formula. W dash is equal to 0.5 times of 1 plus dW minus D divided by B. So we use this formula to find that. Now let us take W dash is equal to 0.5 as per this statement. Okay. So here now W dash is equal to 0.5. Then what about gamma term? So gamma with the last term of the bearing capacity equation will become gamma saturated now, because the water table is at the base of the footing. So gamma in the last term becomes gamma saturated. So the first two terms of the bearing capacity equation will remain unaffected. Okay. So only last term we are changing now. So half into B is the width of the footing, that is 1.8 into gamma, that is 19.5. The previous example I have given this value into N gamma, that is 35.21 into S gamma 0.76 into D gamma 1.152 into I gamma, that is 1 into W dash is equal to 0.5. Okay. So we will calculate, we get this answer, 270.51 kilonewton per meter square. In the previous answer, it was 501.34. Okay, total this value. Now, you have to calculate the net ultimate bearing capacity. So that is the combination of all three terms, right? So the first two terms values remain same. There is no change, means you can use this value. Okay, we have used this formula. So 445, this is the formula, right? CNCSDCIC, this is the formula. So when we substitute, we get, this is the answer. First term 445.5, second term 869.05, third term was 501.34, but now it is changed to third value, that is 270.51. So first two values remains unchanged. So write the same values, 445.50 plus 869.05 plus 270.51. So we will get 1585.06. Now we have to calculate the safe load. What is safe load? That is nothing but safe bearing capacity, not load. Bearing capacity is divided by QNF divided by factor of safety plus gamma into D. So that is 1585.06 divided by 3 plus gamma 18.07 into D, depth of the footing 1.5. So we will get 555.46 kilonewton per meter square. This is the safe bearing pressure. We have to calculate safe load. What we have to do? We have to multiply it by the area of the rectangular footing. That is, area is 1.8 into 3, breadth into length. So we will get 2996.6. Now it is asked to calculate percent reduction in the load capacity, means we have to compare with the original value, that is without water table. What value we have got here? 3415 kilonewton safe load is equal to 3415. So substitute that initial minus final divided by initial into 100, that gives the percent reduction. So initial value is 3415 minus final value is 299.6 divided by 3415 into 100, that is equal to 12.2%. Okay, this is the percent reduction in the load carrying capacity of the footing. Next, let us take the second case, that is 1 meter below the base of the footing. How to calculate that? Here, now 1 meter below the base of the footing means we have to use this formula. It is in between 1 meter below the base of the footing, right? So it is somewhere here. So we have to use this formula now. W dash is equal to 0.5 into 1 plus dW minus D divided by B, that is equal to 0.5 into 1 plus dW minus D, that is nothing but ZW, location of the water table. It is somewhere here. Okay, because total depth of the footing is from here to here 1.5. Now water table is located at a distance of 1 meter. So water table is somewhere here, ZW. Okay, that is now what you will get if you substitute in this equation. W 0.5 into 1 plus ZW divided by B. ZW is 1 meter below the ground level. It is given, divided by B. B is equal to breadth of the footing, that is 1.8. So simplify this, we will get 0.78. Now this is done, W dash. What about gamma term in the second and last? First and second term remains change. There is no remains same. There is no change. Only change in the last term. That is the wedge term. The unit weight gamma to be substituted in the last term may be taken as average unit weight of the soil in the wedged zone, because the water table is located somewhere here. So you have to consider gamma average instead of gamma value here. How to calculate gamma average? I have given that formula. Gamma average is equal to 1 divided by B into gamma dW plus gamma dash into B minus dW. Okay, so calculate gamma average, substitute, we get gamma, that is 18.07 into dW, depth of the water table, that is 1, plus gamma dash is saturated unit weight, that is 19.5, into B minus dW. B is 1.8 minus 1, that is 0.8, divided by 1 plus 0.8, that is nothing but B. B is 1.8. So we get 18.7. So like this you have to calculate gamma average using this equation. Okay. Once if you get gamma average, you can find what is the final value. That is half into beta gamma, n gamma, s gamma, d gamma, I gamma, w dash. Substitute all the values. Half into B is 1.8 into gamma is 18.7 here, the calculated value, gamma average value, into n gamma is 35.21, s gamma is 0.76, d gamma is 1.152, I gamma is 1, into w dash, that is equal to 0.78. So we get 404.68. The remaining thing is same like how we have calculated in the first case. We have to calculate QNF, that is the total formula values you have to consider. The first term value is 445.5 and second term value is A69.05. Only the third value term value it is changing, that is 404.68. So we get 1719.23 kilonewton per meter square. Now you have to calculate what is QN, safe bearing capacity. That is nothing but QNF divided by factor of safety plus gamma into D. Gamma is 18.07. This is gamma is original gamma, okay, bulk density value, into 1.5. So we get this 600.18 kilonewton per meter square. Once if you get safe bearing pressure, you can calculate what is safe load, right? That is nothing but multiplied by the area. So 600.18 into area, that is 1.8 into 3, equal to 3241 kilonewton. Now we have to calculate what is the percent reduction. How to calculate percent reduction? That is equal to initial minus final divided by initial into 100. Initial value is 3415, that is example number 1 value, minus 3241 divided by 3415 into 100, that is equal to 5.1%. Like this you can calculate what is the percent reduction for the different cases, means if the water table is given at different depths. I hope all of you understood. Now let us take Strazegi's sum problems. This type of problem I have not solved. Okay, just only the difference is, see, suppose a square footing has dimensions of 2 meter by 2 meter and a depth of 2 meter. Determine its ultimate bearing capacity in pure clay with an unconfined strength of 0.15 Newton per millimeter square. Phi is equal to 0 degree, gamma is equal to 1.7 grams per centimeter cube. Here, Strazegi's factors is given for phi equal to 0, NC is 5.7, NQ is 1, and gamma is 0. What is the change? Difference means here when there is an unconfined strength, you have to calculate, that is QU. So C is equal to QU by 2. This you have to remember always. Okay, when there is an unconfined strength, then C value can be calculated, that is equal to QU divided by 2. Then remaining things are same. Okay, so QU, that is equal to 0.15 divided by 2, that is equal to 0.075 into 10 raised to 3 kilonewton per meter square, or 75 kilonewton per meter square. Gamma is given 1.7 grams per centimeter cube. So convert into kilonewton, that is 1.7 into 9.81. Use this equation, square footing it is 1.3 CNC plus sigma dash NQ plus 0.3 gamma beta N gamma. So substitute the values, that is QF is equal to 1.3 into C is equal to 75 into NC is 5.7 plus sigma dash, that is gamma D, gamma is 16.677 into D, depth of the foundation footing, that is 2 into NQ is equal to 1, okay, plus 0.3 into gamma is 16.677 into B is 2 meter into N gamma, that is 0. So we get 589.2 kilonewton per meter square. This is the ultimate bearing capacity. Okay, let us take one more example, similar type. A purely cohesive soil was tested by unconfined compression. The mean unconfined compression strength was obtained as 50 kilonewton per meter square. Estimate the ultimate bearing capacity utilizing Tezagi's concept. Bearing capacity factor 5.7. So here only one bearing capacity factor is given, that is NC. NQ, N gamma is not given, so let us take it as 0. Okay, so now once if you substitute in this equation what I told in the previous problem, when there is a unconfined compression test, QU has to be divided by 2 to get the value of cohesion. So cohesion is equal to QU divided by 2. QU is equal to 50 divided by 2 is equal to 25 kilonewton per meter square. So now for the purely cohesive soil, only QF is equal to C into NC. Okay, that NQ and gamma term is not there. It's not given. So substitute in this equation what is QNF, that is equal to C into C is 25 into NC, that is equal to 5.7, that is equal to 142.5 kilonewton per meter square. Okay, so like this you can calculate what is the bearing capacity. Thank you.